Hello and welcome back to the channel, and in today's episode I'm going to show you how to make this simple brick breaker classic game. We will be implementing two ways of movement and collision for our wall, and we'll also implement two ways of building our wonderful levels. This is going to be a rather simple one, way simpler than the Pac-Man and Tetris. So yeah, I hope you'll enjoy that. Let's get this party started. So let's start with the project setup. As you can see, I have Godot Engine Project Manager here. Let's go to a new project. Let's browse, find Godot, select current folder, and I'm gonna create new folder here, call this Brick Breaker Tutorial. Select current folder, the renderer is forward, and version control metadata doesn't really matter, but it is all right. Let's create. Let's move that here, and I'm gonna start by bringing in all the assets that we need. So let's create new folder, call this assets, and I will try to bring everything that we need, which is some PNGs and then a font. I am not going to add sound in that game. You can check my previous tutorials, especially Pac-Man, if you'd like to add sound. Let's do some setup here. Go to project settings, go to window, change the mode, stretch mode to canvas items, and also search for clear. Here, go to rendering environment, change the color to black. Okay. Let's start setting things up. What I do pretty much every single time is I create empty main node. This is just my approach. You don't have to do this, but it kind of makes sense, because when you do stuff like adding children to a tree or using autoload scripts, they're gonna be grouped outside of the main node. Let's save this main scene. Let's create a new folder, call this scenes. Let's save it. And I am also going to go to scenes, right click and set as a main scene. So that's going to be the scene that will load every single time. Okay. I believe, one thing that we also need is a camera 2D. And the default settings, I believe, are fine. Let me see. Yes, everything looks fine. So this is the basic setup, and in the next section we can start working on a paddle and its movement. Let's start working on a paddle. It's going to be controlled by the user, and this is the main entity that we control and play with. Let's start by setting up the inputs. So go to project settings, input map, and we're gonna add two actions, left and right. And there we are going to assign A and D. Of course, you can add more, like left arrow, like left and right, and then everything is going to be handled by two sets of keys. Let's go to the main, or we can go to a scene, new scene, create root node from the other node. We will use rigid body as a main node for our paddle. Let's rename it to paddle. Let's save this, save as paddle in the scenes folder. And then we can add a sprite. So sprite 2D, and the texture for it is going to be the paddle. Okay, perfect. Let's see. Let's change the scale to 0.25, so everything is going to be a bit smaller. And then we're also going to add the collision shape 2D. Let's go to inspector on the right and choose the shape to be new rectangle shape 2D. We can drag those pink handles to match our paddle perfectly. And they tend to snap rather easily to the bounds of our sprite. If they're a little bit too big, no worry. I can see that it's also a little bit out of position, right? So let's bring it back to position by resetting it. And now everything snaps perfectly. Okay, the settings which we need for our paddle. Basically, we have to disable the gravity, so the gravity is not affecting our paddle. Other settings does not really matter in that case. All right, just remember that to set the scale on the sprite, not on the paddle itself. Okay, and we can go to main and right click, instantiate child scene, bring the paddle in. We'll move it to position, and the position that I have chosen is 0, and let's go to transform 0, 2, 8, 3. Okay, so bring it to the bottom. And then what we need is a script to move our paddle. Let's go back to the paddle main scene and let's see what we can do about scripting. Let's create new script. We can change its location. It can live inside of the scenes folder, but what I try to do to keep everything in order is to create scripts folder and put it in the scripts folder here. Perfect. Let me just add that so you can see my cursor better. Okay, we extend the rigid body. Let's add a class name so that we can have types that are better autocomplete. Let's start with direction. This is the movement direction, and we're going to set it to vector to 0. We'll need some references. Let's start, oops, not that. Let's start by adding the reference to speed, so this can be changed easily then in the inspector. And we also going to need the reference to a camera. And why is that? Camera 2D. Well, this is because as we move our wonderful paddle, we need to know about the bounds of the camera around it so that we make sure that user cannot move the paddle outside of the game bounds as he's moving left or right. And we'll use camera to get the camera bounds and limit the movement. What else? We will need some onReady things. So onReady, we'll get, basically you can drag. So if you don't know, you can click here in the scene, drag, hold control, let go, and it's gonna create onReady reference. So this is that. What else do we need? Well, this is it for now. First thing that we have to implement, let's get rid of all of that, is the movement. So input event, if input is action pressed left, direction is equal to vector to left, else input is action input is action pressed right direction vector2 right, else do not move at all vector2 0. Okay, so all the setup we need for our movement. Now since this is rigid body, we will apply the movement in physics process because, well, rigid body, we're working with physics. Basically, if you transform the movement directly by changing the position, you can do this in process. If you're applying some velocity or forces, you should do this in physics process. That's the gist of it. Linear velocity is equal to speed times delta, and that should move out of the box. I mean direction, not delta. And that should move out of the box. And as you can see, we have the paddle moving across our screen. The problem is that, of course, we can get out of bounds. So let's handle that already. So in process, we need to find the camera start X, meaning the this is like the left side X bound of the camera. This camera position X minus camera. We need actually to have another variable here. This is going to be camera rect, which is rect2, which is like the bounding box of the camera. So let's set on ready, and this is going to be camera rect is equal to camera get viewport rect, and also we will need a half of our paddle width, half paddle width. This is a float, so I can say half paddle width is equal to collision shape 2D. We need to access the shape, get the rectangle of the shape, the size X divided by 2, and we have to remember about the scale, which we changed. So this is the bounding box of the camera. This is the half of the width of the paddle. Nice. And we can continue here. Camera rect size X divided by 2. Then we have to get the right bound X of the camera. So camera and X is of course camera start X plus camera rect size X. Okay, and now we can write our conditions. So if global position X minus half paddle width is less than camera start X, global position X is equal to camera start X plus half paddle width. Else, if global position X plus half paddle width is greater than camera and X, global position X is equal to camera and X minus half paddle width. Okay, and this is basically, oh, we don't have the reference set. So if you go to main and see, click on the paddle and go to the inspector, here you can see the references, the export variables we defined in our script. So here it misses the camera, so we can just drag can we just, excuse me, sir? I can just go to paddle, click assign, and find the camera. That works too. Let's try this again, and as I'm moving to the edge of the screen, perfect. Now our movement is blocked at the very edge, which is what we wanted. So this is the paddle movement done pretty much. Yeah, maybe just one thing that we should do is, you can see this this delta here, and to make it run the same on every computer, we need to actually multiply everything by delta. But now it barely moves. So we could just bump up the speed like that. It's still too slow a little bit. I'm gonna skip this for now, right? Doesn't really matter for a game like that. It should run smoothly nevertheless. Just remember that any force or transfer calculations should pretty much always apply delta. We can skip this in that case. So this is the movement of the paddle done. Next section, we'll start working on our ball. Let's start working on our ball. Just adjust the microphone a little bit. Okay. Yeah, let's create a new scene. We'll use, interestingly enough, character body 2D. And we need to add a sprite. Let's switch to 2D. And somewhere here I have a ball. And let's rename this to ball. Save scene. We will change the scale to 0.25. Perfect. And now we can add collision shape. So this is circle. Let's make it match our ball. Perfect. So if you wonder, this is 42 pixels of radius. And basically we can start scripting. So let's add a ball. We can get rid of pretty much everything here. This is the base script that we don't need. Class name ball. We will set the limit of the movement speed for our ball. So let's set the velocity limit to 40. And we will export some variables here. So it starts with ball speed and set to 20. And we will also have the amount of lives here. Okay. As our ball starts bouncing off, we will speed it up. So let's add speed up factor and set it to 1.5. So each time our ball hits the paddle, it should be sped up by 5%. We will need the reference to the collision shape. Perfect. We will also need start position. Use vector 2. And we can add the rest as we go. Let's start with ready. And here we only need to remember our start position. Cool. So then we will create a function called start ball that we'll use to start our ball. Every time we do this, we'll reassign the position to the start position. We'll call randomize to set up the randomization seed. You can read more about it in the documentation. And we will randomly set our velocity. So velocity is vector2, and we will set random range from -1. Oh, sorry, not random number, rand f range from -1 to 1 for x, and for y we'll use -0.1 to -1, and this will pretty much guarantee that our ball will move upwards towards the bricks, not downwards towards the collider. And I found it to be fair for the user because he has time to figure out where the ball is moving. Let's normalize it and multiply by the ball speed. Perfect. So now the only question is, where should we move the ball? And I believe the right answer to this is we should move the ball when the user makes a first move with his paddle. Add the highlight here. So yeah, with that set, we can go to main. We'll add our ball. Okay, let's put it a little bit like here. So 0, 1.15, 1.2. So then in our paddle, we have to have the reference to our ball to call the start ball method. So go to paddle, and I will create a reference here. Or basically, do we need a reference? We can also do onReady. So onReady ball, can grab it by going up and down to a ball as ball. Also, in that case, we need to add is ball started flag, which is false at the start. Okay, then in input, what I can say is if direction is not equal to vector2 0 and ball is not started, I can call ball start ball and set this flag to true, so that will only run once. Let's see whether this works. And the answer is no. It's not moving at all. So let's see what we did wrong. We set the velocity, oh, of course. For the character body, the velocity, setting the velocity itself is not enough. We have to go to physics process, and we have to call, in our case it's gonna be move and collide velocity times ball speed times delta, and we have to go to our ball and we will set the motion mode to floating. So change this one, and now you can see our ball is moving, and it always moves like kinda up when it comes to y-axis. Okay, the one problem that you can see out of the start is that it's gonna just go and go. So we need a way to stop it. And to do that, we'll simply put some walls. So let's go to main. I'm going to add a child node, empty node. And you can use the empty nodes to group other nodes. So these are like containers. I'm going to call this walls. And here I'm going to add child. This is going to be, I'm going to create new scene. You know what? I'm going to create new scene. So let's find rigid body. Let's call this wall. And let's start working on our wall. The only thing it needs is the collision shape. So I'm gonna add that. Let's choose the shape, rectangular. Let's see. I have some values here. So 1164 and 20 is good enough. Save this as a wall. We don't need a script, and we will freeze the rigid body, making it basically a static, like a wall, because you know it is a wall. Let's go to main, and now we can add the walls here. So let's instantiate child scene. We need a wall. You can just put it like here. Let's check the transform. -334, and that's gonna be like the upper wall. Let's duplicate it, and we can rotate it on 90 degrees, and we can move it to here, and let's see, -0.86. The Y doesn't really matter, as it has just to offer it has to cover the whole wall of the camera. So, and yeah, you can see that the Y axis is pointed here now. This is because we of course rotated our wall, and this is the left wall, and then we need to duplicate that. So I do it with Control D, and then right wall, and we will move it. So this is -586, so this has to be of course 586. Perfect. And I believe now it is a good time to do a little bit more of configuration. This is going to work, but we can make it a little bit smarter. So go to project settings, general, and search for 2D physics, and we are going to add some layers here. Oops. And the layers are as follows: ball, paddle, walls, brick. Cool, let's close this, and we can assign these to its specific layers. So the ball, let's go to collision. Ball exists on the layer 1 and can interact with paddle, walls, and brick. Then the paddle exists on layer 2 and can only interact with the ball. And remember to set this because we don't want our paddle to interact with the walls. Then the walls. Each wall exists on the layer 3 and can only interact with the ball. Perfect. So do we have that working? Okay, yeah, you can see our ball is getting stuck to the wall, and we need to fix that by detecting the collision. And first we'll do it in a rather stupid way, but we'll make it smarter as we go. So move and collide is actually gonna return you the information about collision, right? And sorry, about collision. And what we can do is, if we collide it, if there's no collision, we can just return. Okay, early returns are better than nesting ifs, always. So what we can do is we can just say new velocity is equal to velocity bounce collision get normal. And now we have our ball bouncing off of the paddle and too slow, and off the I'm not gonna make it, and off the walls. Perfect. So this is the basic behavior for our ball, and in the next episode, as you could see, when the ball just goes beyond the bottom border of the camera, nothing really happens. So we have to fix that, and we'll do it in the next section. Okay, so in this section we'll try to handle the loss of life and restarting the game when we lose all lives. So let's go to the main, and what we can do is we will just create a new scene. This is going to be area 2D. We will simply add a collision shape to it. Make it rectangular, size 1164. I'll save this, but change the name first to so sounds cool enough. Okay, and we will attach a simple script to it. Get rid of everything, and here we need to go to the node tab and let's see. Oh, go to area 2D and search for body entered. And we'll connect here, and we'll simply re-emit a simple signal, and signal is lose or life lost. And if anything enters this depth zone, will emit the signal. So life lost, emit. Also add the class name, because why not? So depth zone. Okay, we'll need to add this to our main. So Control Shift A, add the depth zone. Of course, position it way below. Here is good enough. And then in our ball, we need to have the reference to it. So let's go to export, and let's export var depth zone, which is of type depth zone. Perfect. And already we'll do depth zone life lost connect on life lost, And we'll have to do some stuff when we are losing life. But for now, let's keep it simple. Let's say on life lost. Life minus equals 1, so subtract 1 from the lives. If lives are equal to 0, we'll have some kind of game over here. But for now, let's make it pass. Else, we will have to do some stuff. Like we'll have to stop the ball. Right, yes. And this is going just to reset the ball. So maybe reset ball is actually better name. And this is going to set the position to a start position. And we will reset the velocity to vector to 0. Perfect. And also it would be nice to somehow inform the user how many lives he has. So I believe this is the right place for us to add a very simplistic UI. So let's add a new scene. And the root is going to be canvas layer. Let's name this UI. Save it. And let's start working on it. So we'll have margin container first. Let's make this spread across. And the values for it, let's go to inspector, theme overrides, enable everything, 16, 16, 16, 16. Perfect. Let's add 8-box container. And let's add a label. Call this live label, lives label. We have to position it so top. Okay, this is perfect. Let's see, lives equal to 3, but we need to do some overrides. So let's set the font, and we have one here. This is the basic pixel-like font I always get from Google. You can see it's kind of blurry, but you can go to texture and filter and change it to nearest for it to sharpen up. And font size, I went with 42 pixels. Okay, cool. And let's add a script. This shouldn't be in the scenes. This should be in scripts. Okay, and let's start working on that. Remove everything. Let's see. Class name is UI. Let's add a unique name here. And if you don't know what unique name is, if I would like to get already reference here and I would drag and hold control, you see that we have to traverse whole path to get to the last leaf of the tree. And this is okay, but it can get a little bit long. So what I can do instead is right press and set and click access as unique name. And then if I drag and drop, you can see that % here, meaning this has been given unique name and can be accessed in this shorter way, which is very nice. Okay, let's do set lives. And this is going to be label, text, lives, %d, % lives. And that's gonna handle the issue of our, oh, that should be lives label, and now we can display and change the lives. But we can do more, and what we're going to do is we're going to add a container here for when we lose our lives, meaning we will lose the game. So let's find this center container. Let's make it span across. Okay, and we can add a panel here. And for that panel, I'm going to set custom minimum size. And in theme overrides, I can choose to create new style box flat, and that's going to allow me to set a color for this, and let's make it red. And then I can add the hbox container, or sorry, box container. Let's make it span across, and what I can do is add a label, and I can add a button. I can say restart game. Here I can say you have lost. Let's align this to center. And we change the alignment here, alignment center. Perfect. So we have that. What else do we need? We probably need the, and you can make this way prettier, play with it a little bit, right? But we need the information about the press of the button. So let's change this to game over, or better, game lost button. Here, game lost container. Make this accessible, or no, we don't even need that. Let's go to node and connect the press signal on game lost button press. This is correct. And here I can just say get 3 reload current scene. And then when we lose a life, we need the reference here to the UI. Okay, like that. I can go to main, press on the ball, go to inspector. Now I can assign the dev zone, and I can assign, oh, I don't have UI here. I can instantiate one. Control Shift A, add UI, but as a child of main. Okay, and then I can go to a ball, reassign, oh, here, and assign everything that I need. Okay, and with that, whenever I lose life, I can reset the ball, and I can say UI set lives, and also here at the start, UI set lives. Okay, let's see how that works. Oh yeah, this is visible from the very start, and this is not what I wanted, but I can go to UI and just toggle the visibility, but then I need to make it visible. So actually we can start working on this right away. So in UI I can just write game over and get the reference to that. And say game lost container show. Okay, and then in a ball, the game is over. So here we can say UI game over. Try this now. Okay, see if everything is working. You should lose a life. Yes, and then yes, whenever the game is lost or whenever we lose a life, our paddle should also be able to restart the ball, right? So we will just emit a signal here. Let's go to the very top and let's say life lost. And here we'll emit the signal life lost, emit, and then in paddle, in a ball, I can just say ball life lost connect, and here I can just say something like on ball lost. Okay, perfect. And whenever that happens, we set is ball started to false. Yes. And we'll set the direction to vector to 0. See how that works. Okay, let's lose the ball. Okay, perfect. Lose the life. And let's try losing the game. Yes, and if I press restart game, everything is restarted. Perfect. So that's how we can handle the loss of life and the death of our player. And in the next episode, we will, or in the next section, we will start working on the bricks. So yeah, let's do that. In this section, we should handle brick and brick spawning for our game. So before we get to spawning the bricks, we should define the brick itself. So we can do it by just going to scene, new scene, and we're gonna search for rigid body 2D. Then what we need is the sprite for the graphics representation, and we can just get any brick really. Let's go to let's first rename this to brick. Then let's go to scenes, let's save this, go to 2D. I believe what we should change here to, at least for the sprite, is the oh no, we can leave it as it is. We need a collision shape, of course. Let's add one. This is going to be new rectangle shape. Let's make it match our sprite. So let's drag those handles into place. Okay, this looks good enough. We need to add a little bit of configuration. We'll make it kind of static and we'll lock rotation. And also we have to disable the gravity scale. Set to 0. Perfect. And then we'll add a little bit of scripting. So let's add a script here. We should place this in scripts. Perfect. And we can code away. So first is of course the class name. This is pretty standard, right? Class name is brick. We'll have a signal that we will emit when the brick is destroyed. We will also have a level here, and the color of our brick will depend on the level, because as you're playing the brick breakers, there are some bricks that will break after just one ball collision, but also there are some that will break after 5 or 4. It depends how we will define this. Okay, let's get the references to the stuff that we need, and then we can start coding. First thing that I'm going to do is we will create an array of textures to change our texture in a sprite dynamically, and I'm just going to grab and drag. So there's a yellow, then there's blue, orange, green. I'm just dragging and dropping with control. Green, then there's gray. Let's just paste this correctly. Gray, and then there's red. Okay, perfect. And then we can start working on those. So we'll need the get size function, and it's going to return collision shape 2D shape get rect size. We'll also need a function to set the level, set level, and we're gonna pass a new level here, and level is equal to new level. And also we can dynamically set the sprite to the texture. Let's add a clone here. Texture by saying sprites new level -1. So this function is gonna allow us to dynamically change the texture of our brick. And then we'll add another helper function, and we will call this decrease level, and we'll call this function anytime we collide with a ball. So if level is greater than 1, we can just say set level -1, else we can call another helper function and call this fade out. And we will do pretty cool stuff here. So first thing we have to do is disable the collision shape 2D. So disable to true, so it will not receive any more collisions. So this is the way for us to disable all those collisions. And now we'll use a twin to basically change the opacity of our brick and make it fade out. So you know that we can do animations with animation and animation players, but these are frame dependent, and you just create those animations frame by frames. Maybe you set it to loop, maybe you add some events. But twins are more like programmatic animations where you can change the property and you can specify the animation by code. So to create a twin, we call get tree create twin, and we will tween the property. First you have to pass the node where you would like to apply the tween, and in our case is sprite 2D. What would you like to change? I would like to change the modulate, which is like the color. I would like to change it towards color transparent. And how long should it take? 0.5. And what is really cool is that I can also add a callback when the tween is finished, and I will just create destroy function here. So we have to create that function. Get no fade out. Sorry, no, destroy. Of course. And then I'm just going to call QFree and brick destroyed emit. Okay, so this is going to happen when we destroy the brick. And also at the bottom I'm going to create another helper function, get size x. And this is pretty much everything we need for our brick, but we need to have a way of placing those, and we will do this by creating a node. So let's go here, add node. This is going to be empty node, and this node is going to be responsible for managing and spawning bricks, and I'm going to call this brick spawner. And I'm also going to add a marker to D. You will see soon why. Let's place it maybe here. Okay, we need to write a script for our brick spawner. So let's go to scripts and let's write brick spawner, and let's create that script. So as I said, we will be having two ways to spawn our wonderful bricks. First, we're gonna implement the simpler one. So let's do the class name brick spawner, and let's do some definitions. So columns I'm gonna set to 5, then rows I'm gonna set to 6. We need some references here. One reference we need is a ball, the other is UI, so let's control drag and drop it. Also we need some exported properties. So I'm gonna say provide the brick scene. We could also preload this, but this is fine. Also let's allow to set the margin between the brick rows and columns, and I'm gonna set this to 8 and 8. And also I'm gonna use that that marker to set the y axis value for where the bricks should spawn. So again, this we will be spawning. This is the margin between column and row of our brick set. And then we'll use this marker 2D to basically set how high in our camera, in our scene, should the bricks spawn. Also let's add brick count and set it to 0. Okay, we don't need the process. And we will write our first function for spawning, the simpler one, spawn. So let's quickly go here and let's provide the brick. Margin is set to 8 to 8 and spawn start is marker 2D. And now we can start coding. So let's start. We have to obtain the size of our brick before we actually Well, do we need the... because there are a few ways to do it. Let's be smart about it. Okay. Let's create another variable here and call this brick size. Is that correct? No, let's make it good old way. Okay. Basically, we need to know the size of the brick before we start placing our bricks. And we can do this by spawning the brick as a test brick. So brick scene instantiate as brick. And we will go down and we will say add child. Use space. Okay. Oh, it's not indented? Come on. Now. Add child test brick. We can take the brick size and say that this is test brick get size times 0.25 because we need this scale for our brick. So maybe there's a better way to do it actually. Let's go to the brick. Let's go to transform. Let's change the scale here. Go to 2D. We have to adjust this to make it smaller and make it fit. And also this should be 0, 0. Okay. Now it's correct. Okay, and in our get size, we have to take into account the scale. So this is basically sprite to the scale. Cool. We have to remember that this is scaled, and you shouldn't really scale the rigid body. You can, but it may come with some unpredictable results. So it's better to keep that transform at 1 and scale everything else. Okay, so now we can go to our brick spawner and say this is our brick size, and since we know it, we can remove this pretty much out of the way. Perfect. Now that we know the brick size, we can calculate the row width. And this is brick size x times columns plus margin x times columns minus 1. Because we actually have a margin. We have margin between every single brick, so the number of the margins is columns minus 1. Then the spawn position for the x value, so let's call this spawn position x, is equal to row width divided by 2 plus brick size divided by 2 plus margin x divided by 2. And if you know your math, you're gonna know that we can just do this, because we have to find the middle of the first spawn position, not the left or right edge of it. And then spawn position y is just equal to spawn start position y. Perfect. And now we can spawn our bricks. So for I in rows, for j in columns, we can spawn a new brick. We don't need to rescale it. We need to add a child. So brick. We need to set the level, which is brick. Oh, we should cast this to have the autocomplete. Brick set level rows minus I, and then X is spawn position X plus I times margin X plus brick get size. Yes, and then var Y is spawn position Y. Sorry, that should be actually J for the column. Yes, and here is for the row, so plus I times margin dot Y, and we should also take the X value here. Okay, so this is how we can calculate the X and Y position. Only we need to multiply here. And then we can just call brick set position vector 2 X and Y. And that pretty much should allow us to spawn everything. Oh, what else? Oh, we need to say brick destroyed, brick destroyed connect on brick destroyed. Perfect. On brick destroyed, we will say brick count minus equals 1, and if brick count is equal to 0, we will do ball stop ball, and we can cast this, and we will have to do also something for our UI, but let's see whether this works. And the answer is no, and this is because we have to call this spawn here. We're doing something wrong for our spawn position. That should be brick size X. Okay, yeah, well, we have something, but it's definitely not working. So one thing that we have to do is go to brick, and in collision we have to put it in the right place. So this is not a ball, this is a brick. Okay. Okay, this is still not working correctly. So we have few things to fix. First thing is in our ball, because we have a collision here. So we have to decide what should happen if we collide with the brick. So if, let's get the collider here. So collider is equal to collision get collider, and if collider is brick, we can just say collider decrease level. Okay, cool. One thing I can see is that this is 8 and 8. So this is correct. This is 8 and 8, so this is correct. But it still does not look good when it's spawning. Of course, there's a mistake in my calculation. When we're setting the spawn position X, it should be minus row width, as we need to push it to the left. And now you can see that we're spawning in the middle, so we can have that perfect gameplay. And I can see that my paddle should be set to move faster, otherwise the game will be too hard. So let's go to a paddle, let's find the speed and let's bump it up to 300. Maybe now it's going to be a little bit easier to play. Okay, and one thing that I would like to fix, as you can tell, is actually the behavior of our ball, because the way it bounces back right now, it's very predictable, still mathematically correct, but very boring. As you can see, it is working, but it can put you in this very unpleasant state, right? So maybe there's a better way for us to calculate the ball movement, and I believe there is. Okay, and I can see that my paddle can be rotated, so let's go to a paddle and we should lock rotation. But basically this is it. We have the bricks spawned right now. The next thing that we should add is actually better movement for our ball, and maybe a better way of spawning our bricks, because there is one and we can add it. So we'll do that in the next section. Okay, so let's try and improve the bouncing code for our ball. So let's go here, and we have the collider. We know what to do when we have a brick, and we will add another function here. So we'll check what type of collider are we working here with. If we're working with a paddle or we're working with a brick, then we will call ball collision and we'll pass the collider. Else, we know that this is the wall and we'll bounce normally off of the wall, but let's fix or improve rather how we handle the collision for our ball. So ball collision collider. Okay, we need few variables here to do our calculations. So first we need to know the ball width, and this is collision shape 2D, shape get rect size X, ball center, this is simple, and this is just position X, collider width, this is collider get width, and we can do that because if we go to our brick we have get width, and if we go to our paddle we have, we should have get width here. So let's add that real quick. See, in GDScript you don't have interfaces, but Normally I would handle something like this with an interface, but nevertheless we can figure it out. This is pretty much the same code. Get rect size x. Okay, now it should work because we have that function get with implemented in our paddle and in our brick. Okay. Yes, moving on. Go to ball. Oh, the mouse highlight. Forgot to turn this on. We have the width. We need the center of the collider. And this is collider position X. Let's change the name here to match everything too. Okay, so first we need to have to get the magnitude of our velocity. So velocity xy, I will call this. And this is velocity length. Then we need to calculate the position of the ball relative to the center of the paddle, and we have to express this as a number between -1 and 1. Of course, the collision at the end of the paddle may exceed this range, but this is fine, we'll handle this. So collision x is ball center x minus collider center x divided by collider width divided by 2. You can also declare new velocity, and this is vector to 0 for the start. And we may say that the new x speed should be proportional to the ball position on the paddle, and also we have to make it relative to the original speed and limit it by some factor. So let's do new velocity x, this is velocity xy times collision x. Okay, and then what we need to do is, let me run the paint. Imagine that this is the set of your bricks, and let's say that this is the paddle, and let's say this is the ball. There might be a situation where, let's start, let's use that color. When the balls go to we can have this, no. The ball goes here and here and start bouncing off of the upper wall, and it will hit the same brick continuously, right? Because of the angle of the collision. And if that's the case and we hit the same brick twice, we would like to change the angle of the velocity, meaning push the ball off of the same brick, because then it will just keep on going up and down. And we can do that just by getting the ID of the collider and comparing it against the previous collision and saying, hey, you struck the same thing twice, we should bounce you into the random direction just to make the game more interesting. So we can do that like this. If collider get rid is equal to last collider ID, and we'll define this at the very top. For last collider ID. Okay. And we have to check if collider is brick, then new velocity x is equal to new collider is brick. new velocity x, new velocity, sorry, rotated, rand range minus 45 to 45. And this basically in radians. So we need to go here and change it to degrees to radians. X, and let's say times 10. Okay, just to move it more. Else, that's not true, then we can just assign the new collider. Perfect. Now we have to calculate the y velocity. And basically basing on the, we can use the sort of Pythagoras theorem, you know, the squares and the square roots to calculate the y. So based on the new speed, x speed, we can calculate the new y speed such that the overall speed is the same as the old, because this, we don't want to change the magnitude of our velocity, right? The y should always be non-zero as long as the x speed is less than the original overall speed. So we can do sqrt square root of absolute float value of velocity xy times velocity xy minus new velocity x times new velocity x, and then we also have to multiply this by -1 if velocity current velocity y is greater than 0, else 1. Okay, also we could do something like speeding our ball up to make the game harder. So I can say speed multiplier is speed up factor if collider is paddle, else it should be the same. So we only speed the ball up whenever we hit the paddle, not when we're hitting a wall or a brick. And then finally we can say that the velocity is equal to new velocity times speed multiplier, and then on all of that we should not allow our ball to exceed some final value, so we can call limit length with the velocity limit. Okay, let's see how that works and if it works at all. So this is the collision. Maybe we should speed our ball a little bit more. Let's see where it will go. Okay. Yeah, and now you can see if I try to, that there was the situation where we hit some bricks the same times. You can see that the ball is speeding up. And also if I hit my ball with the side of the paddle, it's gonna go in that direction. And I'm gonna just speed my paddle a little bit to make it easier for me to play. So if I'm going to hit my paddle with the right side, the ball is going to go to the right side, not by the calculation of the normal as previously. And if I'm going to hit it with the left side, it's going to go more towards the left. Maybe I will be able to present that to you. No, not in that case, but let me try. You can see I bumped it with the left side and it went to the left. Let me try right side right now. Yeah, it goes to the right and now it goes to the left. Maybe the ball is a little bit too fast for my liking. Maybe we can decrease the speed at the start. So go left. And now I will try to make it go right. Perfect. So this is how we can improve our bouncing for our ball. The next section, we will basically try and change how we're spawning our levels, and also how to do multiple levels with very little code, and we'll make spawning of our bricks more declarative. So I'm going to see you in the next section. All right, so how can we spawn our bricks better? And I'm going to start by creating a new script. This time we'll go here and create new script. I will call this level definitions. Okay, let's see. Let's unfold this and let's go. And let's get rid of pretty much everything. It can extend the node. What we'll do, we'll define a variable here called current level, and it's going to be 1. And we will define our levels as an array of arrays of numbers. Meaning, for example, if I would like to create a level that has only one row of bricks of, let's say, 5 bricks, all level 5, I would go and do something like this. Five, 5, 5, 5. And then maybe I would like to add another row, maybe with 1, 2, 2, 3, 4. Okay? The only thing that matters is for us that every single inner array has the same dimension, right? So we have 5 entries here and 5 entries here. But we can make it even smarter. Let's say that this time I would like to only have 3 bricks in the middle. I could put 0 and then any non-zero number. And this then means empty space. So let's try this again and maybe do something like this. Okay, so this defines how my bricks should be placed on a grid. Okay, and then maybe I would like to define level 2. That's gonna be harder. I have a definition, example definition right here. Let me just copy it. All right, so 1, 2, 3, 4, 5, 6, 7, 8. A lot of 5s, some zeros here and there. And now we can define as many levels as we want. We just need to use that structure to spawn our bricks. But first we need to go to project settings, autoload, and add that script. So let's find this. Now this is going to be globally accessible and is going to work as a singleton. Okay, and you can see it's global variable. Okay, perfect. So now we'll go to our brick spawner and we will write another function. I'm gonna leave that as it is because we may have it as a reference, but I'm gonna make another function and call this spawn from definition. Okay, and here we'll pass the level definition, and this is going to be array of ints. Okay. Oh, this is not supported. Okay, we know it's array of ints. So yeah, basically we'll have the very same start, but well, basically everything is gonna be the same except some things are going to be different. So maybe let's copy that. We need this, and then we need to calculate the rows and the columns, right? So rows are basically level definition 0, and columns we can take pretty much well, this should be size. Okay, then we can take pretty much any row and get this size. So this is how we get the rows and columns. Now the row width, we need to change that to columns, and also that, and reset. And yeah, now we can work with our code. So for I in rows, for j in columns, first we need to check whether we hit 0. So if level definition I and j is equal to 0, then continue. Go to the next iteration of the loop. If not, then we can basically repeat the code from here. So let me grab all of this, but we'll need to add a few changes. So this is of course good. Set level. We'll get the level from the level definition I j. Then we have the spawn position x. This is good. This is all correct. Okay, let's see. Let's call spawn from definition, and we need to pass the level definition, and this is accessible by level definitions level 1. See where this works? Yes, it does. Perfect. And if I'm going to pass level 2 right now, you can see we can pretty easily change the levels. So now, how do we actually change those in the game? So here in the when the last brick is destroyed, and this is basically us winning the game, we will go to UI and we'll create new method called on level 1. So let's fire up our UI, and we need to add some stuff. So basically we can copy this container and we'll say this is level 1 container. We'll change few things in theme overrides. We'll create new style. Let's view this. Change this to something green. We'll change that to say you have won the level. Here I'm gonna say go to next level. Okay. And then what we're going to do is go to node, disconnect that, create new reference, change the name first to game level 1 button. Can hide the container now, connect to it, perfect. And here I can say level definitions current level is equal to 2 and get reload current scene. And now if we go back to level definitions, I can create something like levels, and in the first place we will have level 1 and then level 2. Okay, and now when we go to our brick spawner and we spawn from the definition, right, we can additionally create a function here, get current level, and it will return levels. Let's return and current level -1. Okay. Yes, that looks good. Go to brick spawner, we can just call get level definitions, get current level, perfect. And then in the UI we should have this on level 1. So on level 1 we need to make our container visible. Level 1 container show. And to test this, we can simplify the definition of our level to something like this. Okay, is this correct? Let's see. One thing that we're missing is, I believe we're not incrementing. Yes, in both cases we have to increment the brick amount. Let's try this. Level definition. Let's see. So get current level. Current level is 1. That should be all right. Let's see. Let's print level definitions, and it's there. Go to get current level and let's print that. And this is null. Interesting. Okay, we cannot use the reference to that before it's defined, so the solution for that is to move this down in a script. And now invite operand brick count, of course, and here it's the same. Okay, now we have a single brick. Let's try and aim at it. Perfect. And non-existent function stop ball. Start ball. Oh, it should be reset ball. So let's go to brick spawner. Let's reset the ball. Let's try this again. Maybe we can get more lucky with the direction. Okay, let's aim carefully. And I missed. Now it should be good. No, I barely missed. Damn it. Let's try again. Bear with me. And I think we're going to hit. Yes, and now we can go to the next level. And we have new level loaded. And basically, that's it. If you'd like to add some kind of, I don't know, power-ups, points counting, maybe sound, this is very good exercise for you. Go for it, do it. But I'm gonna call this done, and I will see you in the next tutorial. And I still have to figure out what we'll recreate next, but some kind of popular arcade game, of course, in Godot. I appreciate your support. The channel has been growing steadily as I started recording about Godot. I enjoy it very much. If you could drop a like, comment, or subscribe, that's gonna help us beat the unruly YouTube algorithm. So thank you for that, and I'll see you in the next one. Goodbye.